This is so typical me. Just sat and done a bunch of talking with my mic off. I unplugged my microphone earlier and plugged it back in. It must have disconnected it out of the profile. Oh, for God's sake, that's very annoying. Right. You know what? Let's pretend that none of that happened. Let's start again. Oh dear. Right. So. Oh, that's not what I meant to go to. Here. Right. So let's start over. now that you can hear me. So I'm going to be playing Microcorruption, which is a capture the flag based on binary exploitation of effectively a microcontroller. It's a MSP430. It's all in the web. The idea is that each of these challenges has you perform binary exploitation on a smart lock which is attached to a warehouse, supposedly, and then when you break into the lock, their operatives can go in and steal all of the pricey gear that's in the warehouse. I did actually originally play this back in 2014. So as you can see, I've completed I think these first 4 and the tutorial 4. I cannot remember any of them. I had to go back and look at the tutorial yesterday to actually refresh my mind on how the whole thing works, and I honestly cannot remember for the life of me how any of these work. So I'm kind of coming at these, despite the fact that I've technically done them before, I'm coming at them from completely fresh eyes. So the idea is, I'll just go into the tutorial. I'm going to skip the actual tutorial because it's a bit slow, but I'm going to go through it and sort of show you how it all works. So this is the debugger you get. So you've got your disassembly here, memory dump, register state, and the current instruction ends. What's going on over there? The idea is that you get a sort of debug view of the device that you're attacking in a sort of lab scenario. You then go through, work out how you want to exploit the device, and then at the end of it, you solve the challenge by going into solve mode, which moves you against the real device, which does not give you a debugger. You just have to put the input into the password field. So the whole idea is that you enter a password, and that password does something to exploit the challenge, which then gets you in when you shouldn't be able to. There is a manual that comes with this, the Lock It All Lock IT Pro. Just going down, there's a little FCC warning, but this is effectively it's just the idea is it's an MSP430 with a sort of HSM kind of device attached to it, where either you don't have a HSM and you just sort of check the password in software, or you do have a HSM and then you have to do something to trick the HSM into being opened, or you've got a special type of HSM, so that HSM would just check the password and job done. Then there's a special type of HSM, type 2, which is one where the actual unlock as well is done through the HSM, the deadbolt unlock. Otherwise, it's all done through interrupts. There's some information here about how the interrupts and stuff work. We'll probably come back to this. There is memory protection, but it's switched off for the first few challenges. Later, you get debt. You have to mess around with that. Yeah, this tells you about the HSMs that are attached, and I basically skip past the thing here because it's interesting. There's a bunch of interrupts. It tells you what the interrupts do. Things like writing to the terminal and setting flags and opening the device and getting opening the HSM device and getting random numbers. And then so MSP430 assembly is actually really simple. The only thing that kind of throws me off a little bit is I'm super used to Intel syntax and they're using AT&T syntax, so the operands are all backwards for me, and the way in which things like memory is referenced is totally different. But it's a little bit odd for me to read, but I'm sure I'll pick it up. Yeah, this is the whole, like, this is a constant, and this is an offset of R0. Like, what? And then you get this, like, @rx for memory referencing rather than square brackets like you get in Intel syntax. But the number of actual opcodes is really small. You've got the, like, mov, add, sub, and XOR. This, which I guess is supposed to just be OR. I'm not quite sure why they call it this. Then BIC, which I think this is actually a typo because otherwise it's identical to, and also there's definitely a typo here because the caret character is missing from here. Because XOR definitely does not set ARC2 to ARC1. And I think this is and equals the bitwise negation of ARC1, but I'm not sure. It's been a long time since I think there's a few typos in this thing. And then of course you've got compare and bit, which is just test. Then there's the concept of the stack, so you've got push and pop, you've got jump, call, and ret, and then all your conditional jumps, and that is the end of the instruction set. So it's very, very small instructions. So let's just go through. I hope everyone can read the text okay in this. It's not like really crushed down or anything. You can put it in minimal mode and make it ever so slightly larger, but it gets a bit silly. Hoping it's readable. So the first thing I want to do here is I want to work out when main is. So it traps on the first instruction, which is up in its stack. But I don't really care about that. I just want to stick with it. So I just want to break on main. So I set a breakpoint on main, and then type C to continue execution. I'm breaking on main. In fact, you know what? I'm going to turn that breakpoint off, and I'm actually just going to let it run and show you how this works. So it pops up an IO interrupt, asks me for a password. So I'm going to put in, that's not the word test. There we go, test, and then send, and we can see that it breaks immediately after the call that pops up the message. It makes it slightly easier for you to debug and every time. And if I just hit C to continue again, we can see that we've got invalid password, try again, bottom, and the CPU needs to be reset. So that's what happens when you fail. So let's reset it, and again, I'm going to break main, continue. So looking at this main function, we can see that it asks us to enter the password, puts, and calls get password, then calls check password. Check password looks interesting, so let's break on that. There we go. I'm going to put in test, and it's broken after the message box pops up. So I hit C to continue, and there we go. So we're in check password. And I'm just going to go up. Leave on. So the first thing that this check password is doing is it's moving the memory at register 15. So register 15 is currently pointed to 439C, and if I look in the memory at 439C, and yeah, you can see that these last ones are 7465, 7374, which is TEST in ASCII, so the test that I put in. So we can say that looking at this, what I can see that it's doing is it's moving from memory into R14, incrementing registers 15, 12, and of course 15 is the pointer of where we're pointing to in memory. I think instead of reading one by one, I think it's like incrementing by it's incrementing R15 by be weird. Let's just step through and see what happens. No, it isn't. Oh, weird. Sure, that works in terms of actually reading all this out properly. But anyway, the idea is it's reading from memory into R14, then looping around and testing until R14 is 0. Because this test will basically just check if the value of R14 is 0. So what it's doing is it's basically looking for the length of the string. It's counting up this R12 each time until R12 contains the length of the string. And then we can see afterwards that there's this compare. So if I set a breakpoint on that, you can just set that breakpoint and turn this breakpoint off, and then let's see. We can see that here, R12, which is here, is 5. And we entered test, so what it's done is it's counted up to 5, so it's TEST and the null terminator. And then of course what's happened is checking against 9, which it is not 9 at the moment. And we can see that if it is equal to 9, it jumps to check password was 14, which is probably somewhere down here. Yeah, it'll be this bit here. And then here is the failure condition. So the whole thing that this password function actually does is just check to see if the character it's an 8-character password. So we can sort of cheat and just go like let R12 equals 9. And now R12 has been updated as 9, and if I hit continue, ta-da! But the problem is you can't, in the real scenario, you can't just edit the registers because you don't have access to the debugger. So let's reset the whole thing again, and then I don't need the main to be breakpointed, but I do check passwords. But not that it really matters because we now know that it's an 8-character password that it requires. So I'll actually just go to solve. So solve moves you into the real target, and I can just put in any. I mean, the word password is obviously 8 characters, but you could put anything like, I don't know. There we go, waffles 1, that'll do. And it's solved. So that's the tutorial. Now let's actually try one. Ooh. Interesting. I've forgotten this pops up. So, yeah, blah blah blah. Oh, it contains some Bluetooth. No default. Interesting. So, let's break my main again. So, this is very, this is basically the same. It's getting the password, checking the password, testing whether R15 comes back from this check password function as, I don't know, comes back as 1, like non-zero. So if it comes back as non-zero, main then, I guess jump to main plus 2a, which is so if we then break in check password, password, and continue. There we go. So, what's going on here? Clears R14. That's just set to 0. So, moves R15 into R13, adds R14 to 0. Compare that to what that means. Guessing that's going to be whatever's at 2400 in memory. Yes. Okay, so what's happening here is there's an early, yeah, okay. So let's if I just start up Notepad and probably make the font bigger so you can read it. Yeah, that's so it's doing R14 equals 0, and it's doing R13 equals R15, and actually plus R14 rather. And it's doing if memory at R13 is equal to the memory at address 2400 plus R14. So it's actually that. Yeah. In fact, it's jump if not equal, so it's so if it's not equal, jump somewhere. I'm gonna guess that plus 16 is gonna be, yeah, it's gonna be this. It's gonna be the clear R15 ret, so that's gonna be basically return 0. Then it's R14 plus is incremented. It's incremented here. Then it's comparing it to 8. So if R14 8, then jump back 2, so it's going to be here. So this is a loop. Okay, so it's, yeah, so what it's doing is, oh, sorry, let me just drop the music down. Is that better? Sorry, I thought I'd got the compressor working working a little better than that. Audio problems. It's gonna be great. Alright, thank you for letting me know. Right, so this is basically, yeah, all this is doing is basically looping over a piece of memory, checking whether this matches what you've entered as a password, and if it ever doesn't match, it returns 0, so it's like an early out, and if it does match all the way and it's the right length, which should be 8 at the end here, so this 0x8 R14 counter there. And yeah, so if we look in the memory, we can see here that this 8 character string exists at 2400. So if we copy that, I am actually just going to go straight into solve and put that in, and we got it. So that's fairly easy. It's not even really exploitation. There we go. This is software revision 02. It was bypassable without knowing the password. Well, no. So they said they removed it from memory now. So now let's just set one with main, continue. So let's look at check password again. Well, I don't want to actually do that. I want to break check password. Continue again. And it's going to ask me a password, so I'm going to put password in. Here we go. Ooh. That's interesting. So what's at R15? R15 is 439C again, which is the location of the password in the password that I entered in memory. And it's comparing it to the literal constant 7A8C. And then it's comparing it again and again. And if they match, interesting. Well, so let's have a look at what these are in. I should load up CyberChef. For those of you who've never used it before, CyberChef is like absolute magic. It's made by GCHQ because why wouldn't it be? And what you do is you basically just click and drag things in, and you put some input in. So like, I don't know, 4A, 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 and you can see that it turns it into ASCII here. So you just drop in like, I want to turn things from base 64 to hex or whatever. So if it's 41414141, you get obviously so here we've got 7A68, and we've got 3B72. we've got these four. Now, I remember reading somewhere. Where is it? If you look at the instruction encoding here, so if you look at the in the disassembly here, we've got the address, and then we've got the assembly encoding, so the actual bytes that make up the opcode and the operands, and then you've got the decoded format of it. And if you look here, the constant says 7A68, but if you look at the encoded form, it's 687A, which means that the endianness, I can't remember which way around it is, little or big. I think it's endian. I'm terrible at remembering which way that one is. It means that basically the bytes are swapped for every other. So this is not correct. Instead, it should be 687A, 723B, 5357, and then 246A. So let's just delete that first one. I think that should be the password. So if we now solve this. Hey, there we go. Let's try the third one. Oh, new hardware revision. It's got a HSM. Interesting. So, again, break main. And continue. Ooh. See, now this main looks very different. We've got this call. Just goes to login. Okay. So let's jump to let's break login. And continue. Which is basically the main function anyway. Okay. Well, this looks very different anyway. Enter the password. Please remember, passwords are between 8 and 16. Moves 1C into... This is get SN. Get SN does. Have a look in the manual. Nothing mentioned in the manual for what get SN is. Let's break there. Continue. Password. Oh, I think get SN is getting the password. Yes. Okay. So password. Right. So this is then going into test password valid. 2400 is where R15 got moved to. Sorry, no, other way around. I hate that. But yeah, so if you look here, the value of the password, the actual characters, is in 2400. So that could be interesting. And then what we got here? The step through. I'm not entirely sure what's going on here. Oh, God, it's got, I was not paying attention. Test password valid. Okay. This is interesting. So it pushes R4. What's in R4? 0. Oh, okay. Frame pointer. So it's moving. Yeah, it's basically making up a frame here, and then you see at the end it's pop R4 and rep. So it's just basically resetting the frame there. Yeah, it's storing the value of R4 in the stack so that it can be used. So it's a general purpose register. I guess in this calling convention, that's right, the callee must clean up its registers, I guess. It's legitimate. So these first 4 is just set up the stack. Let's just step through this a bit. So this is creating a. Then yeah, so it's moving the stack along. So R4, which is 43FC, stack. Move 0 into that. Okay, so it's moving 0 into the stack -4. Oh, I'm an idiot. I hit C instead of S. Let's start again. I don't need that. I'll log in. Oh no, I just want test password valid. Right there. So continue password. Continue again. Breakpoint. There, here we go. So if we just step, moves 0 into stack -4. Really? Move. Check the syntax again. It doesn't really say. I don't really know. No, cheers, Mr. Noda. Right. So I'm not really sure if I understand what that did, because R4 is pointed to 43FC, like here. Oh, okay, yeah. So if this is 43FC, let's just set this to 0 again for whatever reason. Okay. I don't really know what that's doing. Now it's moving FFFC into R14, which is an interesting value to move into there, which is minus. Word mode, and yeah, -4. I thought it was. So moving -4 into R14. Step again. It's adding R4, which is the address of this, to R14. R14 now points to 43F8. 3F8. No. 0 to 8, yeah, which is here. Yes, because the SP is the same. It pushes R14. That. Pushes R15. R15 is currently 2400, which is the address of the password that I entered. Then it pushes 7B. 7D is going to be the interrupt type. So if we look in here, there was a list of interrupt values somewhere here. Yeah, 7D. Interface with the HSM and set the memory, set the flag in memory. If the password passed in is correct, it takes two arguments. The first argument is in the password to test, and the second is the location of the flag to overwrite. So we know that the first argument is, first argument is the password to test. So the first argument is this 2400. So I'm guessing it's pushing in reverse. So 2400, which is the address of the password to test, and then the second argument is the location of the flag. The flag should go into this 00 here. It's I think is F8. So if I step that, and then I don't know whether that steps in. Oh, it does. I can't remember there's a, if I hit help, there is a thing for like stepping out. Yeah, F. So we can see that it completed its operation, but this 0 is actually not set. And then it's doing SXT. Heck is SXT? Pretty sure that was not in here. It is not. So MSP 430 SXT. What? That's so useless. Sign extend byte to word. Okay, so it's doing a sign extension in R15. So R15 is already 0. So it's still going to be 0. So yeah, I can see what's happened here. So it's done this call, and it's basically just said. So where was R4? R4 is at 43FC, right? So 43FC is here at the end, and what it's done is it's taken away 4 from that, which is here, and it's moved that flag from the interrupt, which is from the HSM checking the password. It's moved that back into R15 for us, and then it's going to pop red, and then now that's interesting because yeah. So if you look at here, we've got this minus 4 from R15. R15 is pointed on the stack, and we're putting our password in the stack, which means we might be able to overflow the stack and then overwrite the location where the password is password flag is set. Although I'm not sure whether that'll work. Maybe. Let's find out. So if I just continue now, it's going to tell me that. It's going to tell me to piss off, basically. Yeah, password's not correct. So we reset. So just before we get there, we know that we probably want to overwrite the stack at like 43F0. So let's quickly just do X 43F0, take away 2400, 1FF0, which is this many characters. Now, just one moment. Where have I installed Python on this box? Oh, apparently it doesn't matter, I just got it in path. Okay, so... Okay, now I need to pull up my clipboard. That's a pain in the ass. I'm just going to do it in pad. Because it's much easier. C# to the rescue. So I'm just going to do new string, and it's the character A, and I want it. Below, but let's certain number of. Yeah. So I'm going to 81. What was it? 176. Sorry, I just realised you probably can't actually see. There you go. Probably can see. So I'm going to do that. It's going to output a crap ton of A's. So I'm going to just try doing. Yeah, I'll reset it. And I'm just going to. Test password valid. Blah 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 blah. Test password valid. Here we go. Break test password valid, and continue. Put in my crazy long string. Continue again. It didn't work. So you can see here it only copied a small amount. Maybe that's not it. Well, that's interesting. Connection to the lock has dropped. What? What happened there? So let's break on this again. Very interesting. I'm going to hit continue. I'll put in my crazy string. Let's see. Right. Let's see what happened here. So R4 gets pushed onto the stack. R4 is just 0 anyway. Then we use the stack pointer into R4. Stack pointer was 43FA. It increments R4 by what, 4 bytes? Sorry, no, increments R1. Talking about. R4 goes from 43FA, 43FC. So it's incrementing by a word. So I guess that's what that means. Deck D is a word. Yeah. So then we've got the SP. Should decrease the stack pointer. So the stack pointer is currently 43FA, which is here. Oh, this time it worked. What? Oh, maybe it was actually just like a glitch in Microcorruption or something, and that's what it meant when it says connections to the lockers dropped. It's just like dropped the state on the server side or something. Weird. So now it's doing all of the usual stuff. Push 7D. That out. And it's moving. Where's R4? BFC. Yeah, it's just going to move 0 back in and it's going to fail again. Hit C. Correct. Interesting. Can you tell I haven't done this in a while? Right. Let's read this assembly a bit more. Let's actually work out what happens when it's reading the password. Is this get SN? Where is it? Here it is. Reset and try this. Right. So R14 goes on the stack. That's interesting. So let's get SN. What's the implementation of that in here? Oh, sorry, not get SN. The interrupt. Interrupt 2. Read a specific number of bytes. So that's interesting. It's very interesting. So get SN. Where does this come from? It's called somewhere. It's called here. Okay. It's saying move 1 C bytes, which is what? $28 bytes. Only moving 28 bytes. Oh dear. Right. So it's calling this interrupt, which of course, yeah, it's just doing the interrupt. Yeah, this is the interrupt trap. So then I just go. That's a good point. I'll just put in that giant string and just send. Stack point is at 43F2, but what to do with this? Done binary exploitation. Say that. I was reverse engineering something this week, but that moves 2400. Correct. Ah, now hang on. This moves 25 into 2410, which is here. Then it compares 2410, 77. So, I just run that. See how it's checking here? Yes, I don't know why I was getting so lost in that other bit. It's checking 2410, which is here, which is what I've overwritten, with the value 77. And if it's correct, it just works. So, what I actually want to do is this. So now, if what's the thing to help? What's the thing to set? Oh, you can just let address. Okay, so let hash. That's not, it's and. Okay, so not that. Yeah, I mean, you can now see that 2410 has been set to 77. So now if I continue, it's done it. Right, okay, so instead what we're going to do is, we don't need it 8,100 times. What we really need is like, I think it's just like 32 times I'll do it. I can't remember exactly what the cost. But, so now if we go solve, actually let's do it in the no, we've seen that we can do it. So we should just put this in, and hey, there we go. Well, that was fun. So which one did we just do? Did we just do Sydney, or did we do Hawaii? What we just did? Or... This looks very similar. I think this is the one we just did. Just try the same solution in it. Yes. So, did I just get the same one again? I think I just clicked the same one again because I'm an idiot. This is Hanoi. Yes, okay. Reykjavik. So this is the last one I actually managed to solve back in 2014, which was a long time ago. Oh, this one's got military grade encryption. Just gonna reset this one because this. There we go, so we can read that again. Software release 2. This release contains military grade encryption. So that users can be confident that the passwords they enter cannot be read from memory. The engineer's response would have been sacked. Okay. Ah, dear. I mean, that worked in real life. Right. Oh. Jesus, what is all of that? Some sort of crazy encryption algorithm. Yeah. What is this? What is going on here? There's no main. Oh no, there is main. I'm blind. So let's breakpoint main. I don't think that does anything. It's a main. Oh dear. So move 4520, which is something over here. No, it's not. I'm blind. 4520. here. What's the password? Okay, so that's the string into R14. Then move R14 into R15. Then move 2400 is going to be, again, this is going to be some encryption nonsense. This looks like probably the data that they've encrypted. And then 2400 at the end, which... Oh! So they've encrypted the source code. Because, yeah, so what's happening here is it's setting up F8, whatever this is, which I'm guessing is probably some sort of key value. And it's moving... Is it putting... I don't understand why it's doing that. That instruction seems pointless to me, because if you're moving this value into R14, and then you move R14 into R15, and then you move a literal into R14, and then you move another thing into R15, what's this for? Am I losing my mind? I don't know. Compilers. They'd be crazy. Okay. So yeah, so it puts probably the source. Oh, maybe that's the length. F8. Like 2, 4, F8. Maybe not. So we're definitely gonna have to see what's going on in an enc. So let's go break enc and continue. So we know that R14, I think it was, R14 contains what we think might be a key. R14 equals key, maybe? It was F8. Key, maybe? Or length? But probably the key, because the length doesn't seem to match up to that. And then the other thing that it was passing was R15, which is 2400, which is the location of encrypted codes. Right, so it's passing via registers, it's not passing on the stack. I keep reaching for my F8 key to like step through because I'm so used to Visual Studio. Like sorry, is it F8? Oh, now I'm questioning myself. F8, F9, F11, yeah, whatever the F key was. Okay, so it's pushing a bunch of crap because probably it's going to use these registers, and then I'm guessing at the end it's going to pop them back off. Yeah, exactly, just popping them. So it's just so save these. So step, 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 step. So, you know what? I don't think we care. I don't think we care what enc does, because enc is going to just decrypt stuff and then jump to it. So if we break on the address 2400 and then just continue. Yeah, so our PC is now at 2400, but the disassembler won't show us what's there. So instead what I'm going to do is, this actually does have a thing where you can like assemble and disassemble. So I think I can just take all of this. I think I have to like, let me just load up Notepad++. so we've got all this hex, and for those of you who don't know, Notepad++ has this really cool feature where if you hold the Alt key, you can drag like this and just copy the block section. So useful. So if I then go back into here and then disassemble this, hey look, we've got assembly. I mean, some of this looks like it might be garbage. You can, like... No, there's no way to force the disassembler to just, like, to just show you what's in memory. Like, to show you something at a particular address, I don't think. That's unfortunate. So we're going to have to do it all in here. This is just setting up the stack. Is it 2, 4, 6? I don't know. Oh, we're in next day. This is the oh god, which level is this? It is Reykjavik. Let's see what's going on. So just to catch you up on what's happened is the code goes through and has this like enc function here, and it takes it takes whatever's at 2400 and encrypts it, which actually decrypts it in this case, and then it calls 2400, which means it's calling into the decrypted memory, meaning it's just decrypted a bunch of opcodes. So I've gone into here, and this is all the decrypted opcodes. Unfortunately, I don't think there's a way to make the actual disassembler show you like this bit of memory in the disassembler, so it's a bit of a pain, but I don't know what any of this does, but I wonder if I step. Yeah, so it's still not in the disassembler, still doesn't show you what it's doing. So pushing a bunch of stuff on the stack. So what's the interesting stuff here? It's going to probably call into... it's going to have to do an interrupt somewhere. So what's the interrupt? Int 02. So we're looking for an int 02 really. There's no interrupt. That's interesting. Get it? Int. Interesting. I'm a terrible person. Maybe this is meant to do it? Yes, it's doing something weird here. 436C? Yeah, this is definitely some interrupt thing. So it's going to call into, where is this into? Blonde. Here it is. 458. Well, that's not useful either. Yeah, it does show the sort of current instruction, but it's only in the... Oh, yeah, sorry. You're right. I always wondered what that was for. Yes, that's very useful, actually. I am slightly confused as to... Like, I think this is garbage. Yeah, look, you got invalid opcodes and all sorts, but so 4520 to R11. This jumps 16 bytes ahead, skipping a bunch of stuff, so that's 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16. Lands it here? Let's find out. So, just step. Yeah, so that's adding 4 to R4. Is this? So this subtracts like a fairly big number. FFE naught. So that takes 32 off the stack. Not quite sure I understand why it's doing that, but oh, is it because it's? I don't know. So moves the stack 32 bytes. Where's the stack pointer at the moment? Okay, the stack pointer apparently doesn't exist anymore. 43DA. Yeah, so the stack pointer is now in a bit of memory that the live memory dump doesn't even show. Then it's going to jump. It lands on this Molf B. Here. So, am I right? Then it moves the value of whatever's in R11. Ah, that's 4520. Down here somewhere. 45. Oh no, sorry, 4520. Here we go. So this is the what's the password thing. So what it's going to do is it's going to move. Yeah, so it moves this 4420 into R15. Checks that R15 is not 0. That's weird. Okay, so if R15 is not... so if it doesn't find what's the password in the right location, it loops and increases R11. I am very confused as to what that's doing, but okay. Seems to be looking for non-zero value there. And it calls into 2464. Excuse me. Right, so it calls into 2464. 2464 would be... This is a pain because it doesn't show me the offsets. So instead, I then have to look into like, yeah, where's 2464? I'm looking for 1E41. It's here. I think let's just add 2 to the stack pointer into whole thing. Blah, 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 blah. That returns back. So okay, so this is the interrupt. So this is where it's asking me for the password, basically. And it's going to return back to wherever the hell I was. So let's just step until I get that call. Here we go, so that's the call. So if I then, I should be able to continue on that call. Actually, I'll just step, just to make sure I'm in the right locations. That goes into where I thought it did, yeah, here. That's going to go into the, so if I just hit F. That's interesting. SR? Bit set. Logical order. I don't understand why it's setting the carry flag or whatever. So it sets that. And it returns. Don't really know what that's about. And then it's got me at 2152, which is my 4 to SP. Oh no, sorry, 2152 is, PC is actually at 20. Seems to do this a couple of times. It's like call to 2464 and that. Or what that's doing. You know what I'm going to do? I'm just going to go continue. I'm going to put in the password. I'm going to hit send. And I'm going to see where it breaks. So it's at 3241. Just pop SR. Do we have a... Sorry, 3241 is the... So here we go. So it's this. And then if I step once, you'll get a rep. Yeah. And then when you step once again... So 3150... Yeah, there's only this one location where that is. That's just on the call to go and get there. So we know that was interrupt 2. So 2464 is the interrupt sender. So code at 2464 is the sort of interrupt. What's the word? It's not the interrupt handler. Dispatch, I guess. Int number. So actually, yeah. So this takes same parameters as the instruction. Because if we look in the manual, you can see that int2 here is the gets one, which is what's just been called. So you can see that the two is here. And the other two things are, what is it? It's the address to place the string and the maximum number of bytes to read. So the address is going to be in R15 and the maximum number of bytes to read is going to be 1F. So we know that it's reading 1F bytes from gets. In fact, actually, if I just copy this bit here, this bit is the... This. 1F bytes from gets, and then putting it in memory at R15. And at the moment, R15 is 0200. So R15 equals 02. So if we look at I200, That isn't in memory. Yeah. So that's confusing. Unless it's clobbered the value of R15. I'm a little confused. Yeah, maybe it's like clobbered the value as part of doing it, and we needed to know it beforehand. That's a little annoying. I don't want to have to reset. Now, the other interesting thing. Well, that's that might be a bit of a giveaway. That might be a little bit of a giveaway as to what the password might be. I kind of just want to do that, but I feel like that's cheating. But I think that's all that this is doing. So, like, is there a reference to that memory address? Is it 44... what? 72? No? But it could be an offset from... I think that's all that's doing. Just as a thought, let's just take this and stick it into CyberChef. See if we get any ASCII out of it. Yeah. That. Okay, so that's just garbage. But I think that's what it's doing. I think it's literally just decrypted all this code, but the password is just this. This is secure, right? Question mark. So let's just reset. And just continue. Oh. Keep going. So this is secure, right? Can't tell if that worked. Try it. Oh. Oh. What's the password? Okay. No. So it isn't that. That. Or maybe that's a red herring. Maybe I'm an idiot. Oh, I didn't see what the AOA. I didn't know either. Well. Dear oh dear. Right. So this call's incorrect. Let's hit that. And then continue. Play. Right, that's it. And then step. So we know that the code is still this. Over here. Let's push R11. Pretty frustrating that it's not just like showing me disassembly, because of course obviously in any real debugger you could just do that. Just double check the help, make sure sure that there's nothing in here. So doing a bunch of stuff. So this is the 7F, which is which one's 7F? 7F is this actually opens the deadbolt. So this here is the bit where it opens the deadbolt. So this is the comparison. So it's comparing. So it does a thing, and then it compares R4 24. So let's just continue, because I know it's going to do this. And I'm going to put in. I'm going to do that, so it's super clear. So this is in memory. So it's actually on the. It's actually on the stack. So this is at 43D something 0, 2, 4 0, 2, 4 6 8 A. Yes. This is at 43DA. So that's interesting. So, and what are we on? We're on OpSR. I'll just step again. Yeah, okay, so now we're back to this add 6 to SP. Here we go. I think that's literally the only one. Yeah, okay, so what's in R4? 43FE, which is here. Okay. That's interesting. We're checking for 67AF, which is not actually anything in hex. G. Superscript minus. Weird. Okay. So this is R4 minus 24. So R4 at the moment is. What is it? This. And it's minus 24. So it's 43DA. Which is where we think the password is this first 43DA is here. Right, okay. So it's checking whether the password starts with 67AF. That's interesting. Actually, it's AF67 because it's backwards. Because if then I go step again, this, and if I want to... Oh, okay, so you can read it this, yeah. So if I go read minus not x24 with R4. Oh, well, that didn't work. Why offer that as a thing? So, but we know that it's whatever the calculator said it was. So if we read it 43DA, that's where the password is. So it's got to start with. It's got to start with 67AF. That's interesting. Continue. So let's reset. Let's just run through it. I'll leave it up there actually. Let's enter it in because you can enter hex encoded. So it should be AF67, right? So now we just step. So here's the comparison. So R4 is at 43FE. So CFE minus 24. Core 3DA. So if we read it core 3DA, we've got AF67. Now, is the zero flag set? Zero flag is set. Yay! There we go. We've done it. So now if we solve, and it's what was the value that we needed? We needed AF67. Hey! Oh, that's from the next step. Nice. Now we're into the proper. Oh Christ! Is it 1 AM? Okay. Well, I was about to say now we're into the proper ones because I've not sold them before, but I might call it for tonight. I don't know. Do I call it, or do I grab a beer and carry on? That's a good question. I do like this track. Screw it, tell you what, we'll go on for one more. But give me one moment, I'm going to go and grab a beer. Baby-faced assassin. Pretty good. Available from all good Morrison stores. I'm not sure we solved that last one in the way that they intended, because they've just said here, this is software revision 2, by removing a conditional flag that could accidentally get set by passwords that were too long. But I didn't do that. I didn't use a long password. I just set the password as the hex thing. So that's an interesting thought, because I think if you go into your... just give me 1 minute. I think if you go into your profile, you can see which passwords you've entered previously. Yeah. Wait, have I just gone back in the same one? Or? No, I haven't. This has got some very different code going on. Right, let's see what's going on with this one then. Well, at least this one doesn't have like all this horrible encrypted code of the last one, because that was a pain in the ass. Actually, don't tell me that it does. Right, so we've got this test password valid again. So, what's that? loaded the wrong one? Because this looks very familiar. I think I've loaded the wrong one. I think I somehow loaded that one. Let's go. Oh no. It's different here. Let's just... I have a reason. Okay, is it? And let's continue to the breakpoint. Test password. So, where did the password go this time? It's still in the stack. But there's data here at the end of the stack. And 3C44. No, that's probably garbage. I don't know what all this is at the end here. So, let's see what happens. R4 is... A 43EA, which... yeah, that's the stack point. So, I think this is again just setting up the stack pointer thing. Yeah, so that just zeroes out. Moves minus 4 into R14. Adds R4. Okay. 7D. Ooh. So this is using... so R14 is what? R14 is... so what's happening here is we've got a call to the interrupt function taking 7D, which is the HSM. So the first thing it's going to take is the password, and the second is going to be the flag location. So we've got... the first is R15. Which is 43EE. 43E. Where around here? Read. Oh, that's the. Oh, of course, I'm an idiot. The first is the password. Is here. The second is the value of R14, which is 43E8, which read 43E8 words, is this bit beforehand, so it's this flag before. So the idea is what they've done is they've moved the password read to the other side of where the flag is, so you can't just like arbitrarily put a bunch of garbage and overwrite. Probably. I strongly suspect that this is related to messing up whatever's in this 4400, because like this 4400 and onwards. I don't know what that is, but I suspect it's going to get used further around the line, like here. Let's find out. So where are we? So we're going to do the check. We're going to return. I don't want to know. So then it's moving. Where's R4? R4 is 43EC, which is okay. So it's moving. Value of R15 7D00 for some reason. That means. Oh no, it's moving a byte, sorry, so it's moving 00, I think. Or -4. R4 minus 4 is 7. 4, 3 EC. 4, 3 EC minus 4. It's 4, 3 E8. So if I read 4, 3 8, that's this one before the C. So it's moved the 0 into that location, I think. So if we just quickly set PC equals 4470 again. By let is what I meant to do. So that's moved us back up to the previous instruction. I just want to run this previous instruction again. And I just want to see what happens if I let R15 equals 1. Oh no, it's moving into R15. My bad, it's moving into R15, not the. This is where Intel syntax versus AT&T syntax screws me over. So yeah, it's moving. Yeah, so if I step again, it doesn't matter because it's moving from the byte, which is this byte here, this 43E8, into R15. And it's sign extending R15 because it moved a byte. So if I step again, sign extension of 0 is just 0. Then it's adding 8 to the stack pointer. This is where it gets interesting because if I step again, now the stack pointer is 43EA. Now, that's still before the... Very interesting. So, and then we will return off here. It should... Now that's very interesting. It's going to test R15. That's fine because it knows that we failed that test. So it's going to jump to here. But I wonder whether it's something to do with if you can overflow beyond that into this like 43F0 space. Or even further. Like way down here. How much data can we put into this? Let's just try this again. Like, let's just use the letter Q because it's not likely to come up. That copied a lot. And I'm just going to step out of this and see what the... Because it just said... What was R15 and R14? So the call here was 2, which is... So this the second one is the maximum number, so that was R14. I think that got clobbered if it's not correct. Oh no, it's 200 bytes? Actually, I'm just going to breakpoint that and reset. Oh, I'm an idiot. Yeah. Continue. Right. So R14 is 30 bytes hex, right? But you can see here clearly that if we're going to start writing at 43E8, which sorry 43EE, I think, yeah, 43EE. If I read 43E, like we can read X 30 bytes, which is what in decimal 48 bytes. But you can see here that there's 2, 4, 6, 8, 16. So we can actually read pretty far ahead. We can overwrite pretty far ahead. So for now, if we so if we just put in can see that we've overwritten a bunch of the stack here with FFs. Now that's interesting. Move the stack pointer into R15. And the stack pointer is 43E0. 43E rather. Then it calls into test password valid. Pushes R4. Keep going. So, R4, QC, set by now. We know that the password isn't correct. What happens if it puts? Like, we're overriding all of this data at the end. Not sure whether this is actually going to go. Pushing this 0, 0, I think it's just right to the... Yes, it is. So... It only wrote the letter T. That's interesting. Was it meant to only do that? Oh yeah, okay, I think this is going to be... I want that one. Yeah, okay, so it's writing it letter by... Oh. Is that really how this works? Yes, it writes a single character, I think. With the character to print, yeah, a single byte. Okay, well, that sucks. Okay, so it's 15 is 60, so it's, yeah, and this. Okay, so go down to let's see what happens to the stack at the end. That's, see, here. So we add 10 to the SP, but it's now going to do a ret, but the stack is in FFFF. So, this is now going to... So if I execute this, it's actually going to lock up because it's going to try and jump to FFFF. So you see how PC is now FFFF, which is just garbage. So... It's just got to this like beady bit at the end. Just I'm guessing about 0 of you would get a Buck Rogers reference. So okay, so now we can control PC, which means all we then need to do is point PC. Yeah, look at this garbage. Oh, is that what we overwrote? That's interesting. So there's a few ways around this. We can put shellcode over in this 4400 section. I think it's... Yeah? No, that doesn't make any sense. This 4400 is like up here. Oh no, it is here. Yeah, so we overwrote some code. So there's a few ways to do this. We can just overwrite PC and then point it at... I think we just need... where's the thing to open the... What's the thing to open the... I like doing it this way, actually, yeah. In 07D. So... it should just be... Oh, here. So we can just call it a 4468. I think. Which would mean that... What is... That's a good question, actually. What's H? We can actually do this in ASCII. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 bytes of garbage that we don't care about. So the password that we should put in should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And that. And that should... In fact, it should probably be that because of the endianness. So we just reset this now and just do a continue. We care about that. We care about that either. It's... Oh no, we do want that one. No, we don't want that. Where is it? Just the interrupt that we want. We want interrupt 7F. So where is interrupt 7F? Pretty sure we just did the thing with that. It's down here somewhere, isn't it? 7D. I want that. Just in that. Here it is. Login plus 36. Login 6? Here it is. So this is unlocked door. So we actually want to move to 4446. So I actually got that wrong. Should be DF capital. FD because it's going to be backwards. Need that. So that's where I want to break point. So yeah, that should be hex. Send. Wait, that's not right. Or is it? It was meant to be coming up to here. Oh, did I miss those first ones off? Did I like miss a whole line or something? I'm gonna do the thing of there's an exploitation tool. I've forgotten the name of it now. Something written in Ruby that will generate these patterns for you, so you can tell where in your payload you're supposed to be. Although, yeah. So if I put this in, just this in, let's just reset. So we'll continue. Put this in. I'm going to do a continue, and it's put it in B8 B7. So you can see that the PC has been set to B8 B7, which means that we know that this is the offset that we want. Oh yeah. Yeah, that's correct. Yeah, so each of these is flipped. So what we want is actually, yeah, I totally screwed that up. So there's the B7. In hex. That's why, so that's ASCII FD. So, oh! Yes, I'm a moron. I was thinking it was hex. It's not hex. It's not hex. That's meant to be ASCII. So that's actually meant to be an ASCII password that you put in. So if I just reset, continue, turn off the hex thing, and then put that in, and you can see now that this AAFD has been here. So now, unlock door is up here. I think if we continue, yes, we land on unlock door, and then if we continue, we've solved it. Fantastic. So, pop that in. Job done. So, I'm happy because I hadn't solved that one before. So this is the first one that I've done that I hadn't. Whoops, did not mean to do that. This is the first one that I've done that I've never solved before. So I'm very happy with that. Anyway, I think I'm going to call it a night because I've been streaming for 2 hours. It's now gone 1 in the morning. Finish my beer and then head to bed. So, thank you all for hanging out. Been fun. I've quite enjoyed playing through this, and I think I'll probably end up being back on Friday night. I've got D&D tomorrow night, and then I've got to go to the Hackspace on Thursday. I've got to use the laser cutter over there. In fact, that reminds me I need to alter my booking. But yes, so thank you everybody for hanging out, and I shall hopefully see you Friday night.